Hello, my dear students. Here I am back again with further discussion of the chapter metals and non-metals. In the previous discussions, we were discussing about how metals react with non-metals to form ionic compounds, and we have even discussed about properties of ionic compounds. Today, in this session, we are going to discuss about how metals occur in nature and how those metals are extracted from the nature. So today's concept is occurrence of metals. Metals Metals never occur in pure state in the nature. They always occur as some of the compounds, which we call as minerals. For example, let us take into consideration sodium. In case of sodium, Na, okay, in case of sodium, it occurs as NaCl or NaNO3 or Na2, Na2O, that is sodium oxide. It exists as sodium chloride or sodium nitrate or sodium oxide. Okay, so this sodium which exists in these three forms has to be used to get sodium out of it, which we'll use in the laboratory. Okay, so how these processes are done, let us understand in detail about how metals occurs and how its extraction is done in the nature. Yeah. So these metals are generally available in Earth's crust. It is available in Earth's crust. Even it is available as rocks in the Earth crust, or even in sea water also these metals are available. Earth crust as Earth crust, okay, as rocks or even in seawater. It's also available in seawater. Okay. So now these metals which are available in the earth crust, they're available in compound form, any compound, okay? And those compounds are called as minerals. The elements or compounds which occur naturally in the earth crust are called as minerals. About minerals you have studied in your social science chapters also. Okay, so minerals which occur in Karnataka or which occur in India, you have studied in detail. Minerals are nothing but elements or compounds that occur in the nature. These minerals will have metals in them. Okay. So, for example, say NaCl, NaNO3, Na2O. These all three are minerals. Though these three are minerals, extraction of Na from these three minerals are not of same process. Okay, so that means if I want to remove NaCl from Na from NaCl, then it is quite easier. Okay, Na removal from NaCl is easier, whereas from NaNO3 and Na2O, it's quite difficult task. That is from sodium nitrate and sodium oxide, removal of sodium become quite difficult, whereas from sodium chloride it's easy to remove. Okay, so minerals are those which contain metals in them. Okay, minerals which are easy to extract metal out of it, they are called as ore. They're easy to extract for various reasons. One reason may be it contains more amount of metals. So when I take 1 gram of mineral, and in that 1 gram of mineral there is almost 90% of metal is present. Then when I use that 1 gram of mineral for extraction, I'll get lot amount of metals. It's benefit for me financially, right? So those minerals which are used for profitable extraction of metals are called as ores. So ores are minerals containing very high percentage of particular metal, and the metal can be profitably extracted from it. I can extract Na from NaCl, NaNO3, Na2O, all three minerals. But NaCl is quite profitable to get Na from it. As NaCl is quite profitable, we can consider NaCl as ore of sodium. Hope you understood the concept. All ores are minerals only, but it contain more percentage of a particular metal, which is used for profitable extraction of that particular metal. Whereas all minerals need not be ores, because there may be mineral which contain less amount of that particular metal, which if I use for extraction might become costlier. So all minerals may not be ores, but all ores are minerals. This is one thing you should remember. Okay, so we have understood that metals generally exist in earth crust, either in rock form or in seawater. Okay, in whichever form it is available, we should extract metal from it. Okay, that process of extraction is to be understood in detail in coming slides. So this particular compound or element that contain metal in it is called as mineral. If that particular mineral contain more amount of metal, which if I use to get the metal is profitable, then it's called as ore. All minerals may not be ores, but all ores are definitely minerals. Okay, so let's move further to understand more about how extraction process is done. Occurrence of metals, extraction. Extraction of metals is generally based on its reactivity. Okay, we have studied about reactivity series of metals. Do you remember the mnemonic that I have taught you? PSC, magnesium, hardly could make solid gold perfectly, right? So those metals which are in the reactivity series include at the top, it contain potassium, sodium, calcium, which are highly reactive. Okay, in the middle order we have zinc, and we have even nickel, okay, cobalt, etc. And in the lower order we have gold, silver, platinum, etc. So this extraction process of metals is done based on their reactivity. Okay, the process of extraction of metal is called as metallurgy. This is one word you need to remember. Metallurgy. Metallurgy is nothing but process of removal of or extraction of metals. From where it is extracted? Generally, it is extracted from ores. From ores. That's called as metallurgy. Okay. It's also considered as branch of science that deals with extraction of metals from its ore is called as metallurgy. Okay. So now this metallurgy, extraction of metals, is done based on its reactivity. The metals at the bottom of the activity series are least reactive. Okay, least reactive, which are at the bottom, which include generally Au means gold, Ag, that is silver, Pt, platinum, and Cu, copper. These generally exist in free state. They generally exist in free state. Okay, they generally exist in free state like gold, silver, platinum, even copper sometimes. Okay, it exists in free state. Free state means only we need to remove the impurities present in it and we can use the metals. Extraction process is not that difficult for metals in the low reactivity series. Whereas metals at the top of the reactivity series include K, potassium, Na, sodium, Ca, calcium, Mg, magnesium, and Al. Yes, you have guessed it right, aluminium. All these metals are at the top of the reactivity series and they are so reactive that they are never found in free state. Never found in free state. They're reactive. They want to combine with whoever comes. Okay, so they generally exist in combined form, never alone, always with friends. Okay, in compound form. Now, coming to the metals in the middle of the activity series, which include zinc, iron, and lead. Zinc, iron, lead, which are in the middle order, middle of the reactivity series. They are moderately reactive and they're found in the earth crust mainly as oxides, sulfides, and carbonates. Oxides, that means it will have oxygen in it, sulfides will have sulfur in it, and carbonates will have carbon in it. So metals in the middle order, middle of the reactivity series will exist as oxides, sulfides, or carbonates. Whereas lower order, that is less reactive, free state. Whereas middle order, they never exist in sorry top order, they never exist in free state, always exist as compounds. So this is about how extraction are done based on reactivity. Metals at the top of the reactivity always as compounds. Okay, metals in the middle generally as sulfides, oxides, and carbonates. Metals in the low reactivity series generally in native state. Native state means almost pure form. Okay, though they will have some impurities, but never as compounds. Generally we are speaking. Generally not as compounds. Now let's move further. Yeah, this is how extraction is done. Very, very important. Extraction is done based on these steps. Extraction of metals or metallurgy is not a single step process. It includes various steps. Okay, so those various steps are given here. Ore, which has more concentration of metal. Ore, okay, that ore will be first ore has to be done concentration of ore. What's that concentration of ore? We'll discuss shortly. Okay, first process is concentration of ore for any type of metal in the low reactivity, middle reactivity, or high reactivity. Concentration is must. After concentration of ore, metals of the high reactivity series, they are passed for electrolysis of molten ore. They'll melt the ore and electrolysis is done. Pure metal is obtained. That means very simple process that appears, but it includes various steps which we'll discuss. So first, metals of the higher reactivity series, electrolysis is done and pure metal is obtained. Metals in the medium reactivity, they can either be as carbonate ore or as sulfide ore, carbonate or sulfide ore. Okay, if it is carbonate ore, calcination is done. If it is sulfide ore, roasting is done. Which are those calcination and roasting processes? We'll discuss shortly. After the process of calcination and roasting, respectively for carbonate and sulfide ore, oxide of metal is obtained. And that oxide is reduced to get the metal and purification of metal is done. Then metal of the low reactivity series, they can be as sulfide or sometimes, especially silver. Silver is available as Ag2S. Okay, Ag2S means silver sulfide. Silver sulfide. Okay, so this silver sulfide is undergone roasting first. After roasting, the metal is obtained, and it is refined. Refined means purification is done. So these are the steps, common steps for extraction of ores. How it is done for higher reactivity, middle order, and lower order, that we'll discuss shortly. Okay, then first step that was given is concentration of ore, or also called as enrichment of ore. Enrichment, making it richer. Concentration, making it richer with particular metal, meaning the same. So, what is this concentration or enrichment of ore? Any ore that we'll get from the earth crust will have some impurities. Okay, impurities like soil or sand, dust, or oil will be present in that particular ore. So, those impurities are called as gangue. It's called as gangue. Gangue is nothing but impurities that are present along with the ore. Those impurities can be soil or sand or even oil. It can also be oil. So these impurities are called as gangue. Enrichment or concentration of ore means process of removal of gangue from the ore. When we remove the impurities, then that particular process is called as concentration of ore or enrichment of ore. It is done by various processes. Yes, it is done by various processes, and the processes involved here for concentration of ore mainly involve which type of gangue is present in it. If the gangue is having property of magnetism, magnetic and non-magnetic material are mixed together, then we'll use magnetic separation. Magnetic separation is used if gangue and ore is having magnetic property. Either one of them must have magnetic property, magnetic separation. Or sometimes it is just done by washing. Okay, washing, or sometimes it's also called as froth flotation. Froth flotation is also a process to remove gangue from the ore. That is, enrichment of ore or concentration of ore is done by any of these processes, which are not given in detail. You need not break your head to know what is this froth flotation or magnetic separation or washing. What are these? You need not worry much. It's not mentioned. Okay, so leave it. One thing that you should know, when any ore has to be extracted, first step remain common for any of the metal, that is concentration of ore or enrichment of ore, which means removal of gangue from the ore. Shall we move further? So moving further, let us now discuss extraction of metals in the low reactive series. Low reactive, which are at the bottom, which include copper, silver, gold, platinum. Okay, how those metals are extracted? Generally, they exist as native state. Sometimes silver may also exist as silver sulfide. So metals of the low reactivity series are very unreactive. They are least reactive. They keep distance with others. Okay. So they maintain their dignity. They never mingle with anyone. They're most unreactive. The oxides of these metals can be reduced to metals by heating alone. If these metals are existing in oxide form, if we just heat them, it will lose the oxygen and it will exist as impure in metal form, metallic form. For example, cinnabar or mercury, HGS. HGS is called as cinnabar. This HGS is an ore of mercury. It's an ore of mercury. It contains sulfur. Okay, it contains sulfur in it. This cinnabar, when heated, it is converted to mercuric oxide, HgO. Okay, mercuric sulfide. This is mercuric sulfide. That mercuric sulfide is getting converted to mercuric sulfide is getting converted to mercuric oxide. It's getting converted to mercuric oxide. Okay, so this mercuric oxide is further heated to get mercury out of it. To get mercury out of it. Mercuric oxide is then reduced to mercury and further heating. Okay, so whenever we need to extract mercury from cinnabar, that is mercuric sulfide, it involves three steps. Okay, three steps are there. First step which comes under extraction of mercury from cinnabar is step number 1 is concentration of ore. That means removal of gangue from the ore. First step. Second step is we need to convert HGS to HGO. Okay, so second step HGS to HGO, which is done by a process called as roasting. It is done by roasting. We'll discuss shortly. Then third step is converting HGO to HG. This is done by what is happening there? HGO to HG. You have studied in chapter 1. What is removed there? Oxygen is removed. Process of removal of oxygen is called as reduction. So reduction is done is the third step. Okay, so these are three steps involved in removal of Hg from HGS, that is cinnabar. Okay, now moving further. Yeah, here is these two steps. HGS is there, which heated in presence of oxygen, okay, gets converted to HGO and SO2. It's given as balanced reaction. HGS, which is a solid, okay, is heated in presence of oxygen, that gets converted to HGO, which is again a solid, and SO2 gas is released. Sulfur dioxide gas is released. In second step, here HGO to HG reduction is done just by heating. Just by heating HGO, we'll get Hg in liquid form and O2 as gas is released. Hg in liquid form because mercury is the only liquid metal. Okay, children, let's move further. Similarly, extraction of metals in the low reactivity series will also involve extraction of copper. Even for copper, three steps remain common. Okay, for copper, this was for mercury. Hg. These three steps, whatever I have given here, concentration of ore, HGS to HGO, HGO to HG. Okay. Now, for copper also, it remains same. The first step remains same. That is concentration. Concentration of ore is same. Then second step is converting copper sulfate, Cu2S, to Cu2O. Okay, copper sulfide to copper oxide. Then third step is copper oxide, Cu2O to Cu. Three steps again. Okay, so let us understand which are those three steps. Yeah, Cu2, yes, here it is, right? Cu2, yes, is heated in presence of oxygen to get Cu2O. copper oxide, and sulfur dioxide is released. Then copper oxide is heated in presence of copper sulfide, which is one of the reactant in the first step. Okay, these mixtures when is heated, Cu plus SO2 is produced. Here, this particular step is called as auto reduction. It's called as auto reduction of copper. This particular step is called as auto reduction. Auto reduction of copper oxide. Copper oxide. Copper oxide is auto reduced with the help of copper sulfide. That is auto reduction. Auto reduction of copper oxide. So this is about how extraction of low reactivity series are done. Okay, one we have discussed about mercury, another we have discussed about copper. In case of mercury, 3 steps. In case of copper, also 3 steps. In case of mercury, the ore is called a cinnabar, which is 1 mark question. Okay, what is the name the ore of mercury? Or it can be what is cinnabar? Or it can be what are the elements present in cinnabar? Okay, or write the formula of cinnabar, HgS. That is cinnabar. So first step, concentration of ore, removal of gangue. Second step, HgS2, HgO or Cu2S2, Cu2O. Third step, Cu2O2, Cu, that is copper, or HgO2, Hg. In case of HgO2, Hg, only heating is enough. Whereas in Cu2O2, Cu, it is heated along with Cu2S, which helps in auto reduction of copper. That's all for today, children. Let's meet again in the coming video with further discussion of extraction of metals. Thank you for your listening. Okay, keep share the video and subscribe my channel and like my videos. Thank you for your patience listening.